All right, learning our says chapter 4, unit 6 is what it's kind of called now, intro and activity. Want to remember over here that this symbol is the less than symbol, greater than or symbol is the other one. We might have phrases we've talked about them before in person. I'd show you that less than symbol you can make with your left hand, make that kind of alliteration, that sound with the L, left hand less than. If there's a line underneath it, kind of like part of an equal sign, that's where we get the less than or equal to, or the greater than or equal to sign. So in this unit, we're going to be solving and graphing inequalities. So to start with, when we talk about graphing inequalities, whatever our answer is, that's going to go in the middle. So we got a -3, -2, -1, and 0. It does have to specifically go this way. With those negative numbers, it can get confusing sometimes, but it has to always get greater or warmer to the right when we're talking about those things. So going to the right, always making sure it is warmer and greater. So that's going to be some of the things we have to focus on, as well as when we're talking about these with graphing. The numbers have to be below it. Now, since this inequality says x is less than -3, that's where we're going to have this open circle, and then we're going to shade everything that is less than. All the numbers to the left that are colder than -3 are the numbers we want, because all these numbers over here, -4, -5, -6, so on and so forth, are less than a -3. This guy, x, this symbol, -5. So again, x is greater than or equal to -5. So with that, again, start with that number in the middle, or I usually say middle-ish, because sometimes these number lines don't have a perfect middle. I'm also not that picky that if it's not perfectly in the middle, it's all right. But whatever your answer is, that number has to go here in the middle, and then I always start by going to the right and getting warmer. Yes, it needs to be getting warmer. The numbers need to be getting greater. So that's a -2, -1, 0, so on and so forth to the right. And then to the left, they need to get lower. They need to get colder. -6, -7, -8. Don't ask me why that one's so thick. I don't know. But when we've got that, here we go. Now on that one then, because it's greater than or equal to, that phrase or equal to is like a closed fist, and you want to grab that number because on that -5, it can equal that. And then for shading, in class I talked about how you could shade really thickly if you wanted. Otherwise, just shade, put a big arrow, so that way you and I, everyone can see that you're shading to the right where all the numbers are greater, they're warmer than -5. And we just continue on with all those. So when it's x is less than or equal to 2, put the 2 in the middle, then we go 3, again, warmer to the right, 4, and 5. To the left, get lower, get colder. So yes, the numbers have to go underneath. Yes, the numbers have to go in numerical order, so they do have to look like this. If they don't, the graph is not right. Since it's x is less than or equal to, visually when you see the line underneath, or verbally when you hear that phrase or equal to, that's a closed fist where we're going to shade in this dot because it's a closed fist, because we can actually include the 2. It's like you're grabbing it with your hand and including it. And again, make that shading what's one way or the other. So in class, I'll spend more time where it's either one way or the other, so you pick one side. I think we shade to the left, Mr. Walls. Then pick a number. I like 0. I plug it on in here. Is 0 less than 2? Yes, it is. So I was correct. We shade that direction. Again, when we talk about graphing, we go here, graph that guy. So when it's x greater than 7, x greater than 7, 7 goes in the middle or about the middle. The numbers below must be getting warmer to the right. So 7, 8, 9, 10. They must go up evenly. We can't skip around and do 7, 9, 11, 15, 18, 99. they have to go up the same amount. So you can count by ones, you can count by twos, you can count by whatever you want, but they have to go up evenly. 7, 8, 9, 10. Or you could count by odds. 7, 9, 11, 13. However you count, it's got to go up the same amount. So here I'm going up by ones. It's got to go down by the same amount. So since I went up by 1, I'm going to go down by 1. And with that, again, x is greater than 7. So we're going to do another little activity here quick in a second to see if I pick 7, is 7 greater than 7? Nope. So then that is why we have an open circle, because everything just a little bit more than 7 works. It is greater than 7. So again, now we have to shade one side or the other. You can pick one and then just pick a number. I'm pretty sure we shade to the right, Mr. Walls. Cool. Pick a number to the right. Pick 10. Is 10 greater than 7? Yep. Now, you don't have to write that number up there. I just write it on in, especially here since you're watching a video. Decimals, fractions, we have options. So again, with this, if we were in class, I'd have you put your pencils down, but you're just watching this video here today. So on that, you can put this number here in the middle, negative 2.3. And then from there, if you're like me and you ran out of space, I can go up by tenths. So negative 2.3 is here, negative 2.2 is here. That means this guy here would be in negative 2.1. And if there is enough space, you could write it here too. Some people like to draw arrows. That gets to be a lot of writing, so I tend to, just when I run out of space, I'll just number every other one. So I won't really do that, even though this one is a negative 2.0, which means going to the left, this was a negative 2 4/10, a negative 2 5/10. And that works. That is one way you could do that one. In class, I also talk about, and here I'll do it fast, you'll see in the textbook, they just use whole numbers. So they say, let's go and use negative 3, negative 2, negative 1, 0, and then they use negative 4, negative 5, and negative 6. And then from there, they just graph negative 2 3/10, which is right about here. And they just kind of eyeball it. So the choice is yours. You can count by whole numbers, put the negative 2 3/10 in the correct spot, and then shade to the less than side, since x is less than. Or you can use the decimals. The same goes for fractions. So fractions, you could go 2/5, 3/5, 4/5. That works just fine. 5/5. I would accept that because you're going up evenly each time. You could also do 2/5, 1 2/5, 2 2/5, 3 2/5. Notice again, I'm going up evenly. I'm adding 1 each time as we go through that. So that's just where we have to be careful with that, because if that's how we're doing it, 2/5, 1 2/5, 2 2/5, then we have to be careful when we go down to these negatives. Or again, what you're going to see the textbook do oftentimes is they're just going to say, all right, 0, 1, 2, and 3. Negative 1, negative 2, and negative 3. And since 2/5 is between 0 and 1, just a little bit down here. Oops, don't go like that. Should be an open circle. And then they say, all right, since it's supposed to be greater, the numbers are greater than 2/5. X is greater than 2/5. So if I pick a number over here, like 3, 3 is greater than 2/5. So I've shaded that the correct way. The time of the book, deepest free dive in the ocean was 417 feet. The depth of humans in the Could be represented by the inequality. X is less than or equal to 417 feet. Graph the inequality. Please note, again, you must do it evenly. So that's where I would show you again here. You can't do 417 and then change how you're counting and do 418 here. You can't change your numbers. If I go up by 1, I can't make this next one 425, and then this guy 450. Whatever I'm counting by, it's got to be the same amount each time. These numbers have to change evenly the whole way through. So notice, if I start counting by ones, I need to finish counting by ones. If I'm going to go up by fives, I need to go up by fives the whole way through. Again, though, if you don't have enough room, you can number every other one, meaning since this is 418, I can just number this one as 419. The numbers continue on. Same thing, not enough room. Well, this is supposed to be 416. That makes this one 415. When you write with your pencil, sometimes we can write small enough. When you're writing here on a PDF document, sometimes you can't make it small enough so you can have that number 416 fit in there. But again, here we go. X is less than or equal to. I talk about it in class. Don't go by which way the sign is pointing. That might be a trick we've learned or been taught. We have to answer the inequality. Since the numbers are less than or equal to 417, less than or equal to, there's that phrase equal. Otherwise, the line underneath also tells us it's going to be a closed dot because it can equal it. And then we need numbers that are less than. So let's take a look. Pretty sure I shade to the left. Let's look. Is 415 less than 417? It is. So then you can shade just like this. This might not be very visible on your notebook, but with that obnoxious or that really big arrow over here, we can get that and be done with that. And you can see that that arrow you clearly shaded to the left. We talk about comparing, change them to decimals. So if we were in class, I'd have you all grab a calculator, do muscle memory. 3 divided by 4 is 0.75. And then we can compare how 75 hundredths compares to 2 tenths. You can also add a 0 here, so we have the same amount of decimal places. 0.75 is greater than 0.2 or 0.20. So 75 hundredths is more than 20 hundredths. 3/4 is greater than 2 tenths. So again, you just grab that calculator. You take that top divided by the bottom with those. So going over here to number 9, careful again. We take the top, so that should be 7 divided by 8. And then just, if we were doing this in person, I'd have us write it down. Since I'm doing it for you, I want to make sure you can see that number. 0.875 is the decimal for 7/8. That, again, you can add more zeros over here because we're not talking about the amount of numbers. We're talking about the value. 700,000, sorry, 0.700 and 0.875. When we look at those again, you can compare them. 0.875 is greater, so we're going to put that greater than symbol in there. Again, when we talk about comparing, we have to be careful with the negatives. Negatives are a little bit different. This, when you divide it on out, is 0.6 repeating, so I'm going to add a couple of 6s there with a line over the top. Careful, though, with negatives. Remember, when we talk about those, we want which one is greater, so which one is warmer. So when we talk about two negatives, the 0.60 is the greater one because it is closer to 0. Better phrase is it's warmer, it's greater. When we have a negative and a positive, that makes life simple. The negative will always be less than the positive. An improper fraction, now you could change that quick to 5 2/3. However, you could also just divide it on out. If you take that 17 divided by 3, you get a big decimal like that. Well, that's okay. You can still just see that it's 5 2/3 or 5.6 repeating. So from there, again, the one that is bigger, the 6, or the whole number there is greater than 17/3. It's greater than 5 6/10 repeating. It's greater than 5 2/3. Thus, you say it this way. Again, here's why this symbol is the less than symbol. In class, I'd have you make it with your left hand. Here you're just watching a video where, again, because you read it from left to right. So 17/3 is less than 6. Take and divide those numbers on out. 31 divided by 16, even if you don't get a nice number, or if you do, well, right away, Mr. Walls, it's 1.9, so I know it's more than that. Awesome. Let me just write it on out so we can all see it. But you're right. 1 and 8/10 is less than 1 and 9/10, or 1.9375. Since there are 1, 2, 3, 4 decimal places, you could add 1, 2, 3, 0. So you have 4 decimal places, and then you can look 1.9375 or 8,000. 9,000 is more. So again, your height, 5 feet and 1 5/8 inches. Your friend's 5.6 feet. Who is taller? This you have to change all into feet. So again, we take this guy. You gotta divide that by 12. Or what you could do is 5.6 is not 5 feet 6 inches. 0.6 of a feet. Well, there are 12 inches in a foot. So then what's 0.6? What's 6/10 of a foot? What's 0.6 times 12? Again, that gives us 7.2 inches. So who is taller? Well, your friend is 5 feet 7 inches. And your height is 5 feet and 1 5/8 inches. So who's taller? Your friend. Explain. They are 6 inches taller. Their height is taller. You can explain it many different ways. Now, to understand some of these phrases, like at least, when we talk about graphing, we're going to do this very quickly again. It says work with the partner. You normally would be writing this on in, but since we're just watching the video, I'll do it. When we talk about you're in at least 5 of the photos, circle up the numbers that work for that. At least 5. If you're in at least 5 photos, that means you could be in 5, you could be in 6, you could be in more. What do you notice about the numbers you circled? To save time, I'm not going to write it on out because it takes me too long with the pen on the mouse. But what do you notice about the numbers? They're all 5 or more. So is the number 5 included? Yes. Why? Well, because it is at least 5. Kind of the same thing. I switch it to money. If you asked for at least $5 for the school party, even though you got $5, I'd say, did you get what you wanted? And you say, no, I want more money. If you asked for at least $5 for the school party, if someone sent $5 with you, that is what you asked for. At least 5 means 5 or more numbers. So again, 4 other numbers that make it true: 7, 8, 22, 55, 1 million, whatever you want. 4 other numbers. The temperature is less than -4. In class, we would be doing this, and you do it on your own first, then I talk about it. But since it's less than 4, all the numbers we circled are colder. They're smaller than -4. Can it be -4 degrees? Well, is -4 less than -4? No, it is not. -4 is equal to 4, but it said it had to be less than. So that's why it's not included. Again, 4 numbers that make it true: -10, -3 billion, -3 trillion, whatever the national debt is. All those different numbers work. More than 3 students from our school are in the chess tournament. So these first ones often people will circle up right away. And then again, in class, you have a time to think on your own, but for purposes here with the video to shorten it on up, more than 3 students are in the chess tournament. So what do you notice about the numbers you circled? They're all greater than 3. Down here it says, is 3 included? Well, is 3 students more than 3 students? No. So that's why it is not. Again, 4 of the numbers that make it true, that would be anything greater than that 3. Now, this is the phrase that we're going to have a little help with in our notes when we get to it next time. We were doing notes on that first lesson. There's a table to help us with these phrases. But here, when we don't have the table, the balance in a yearbook fund is no more than -5. So again, in class, you'd circle up numbers first, and then we talk about it. But here, no more than -$5. So could you have $2 in the account? Is that no more than -5? No, $2 is more than -5, and we don't want that, so that doesn't work. So then what we're talking about is, for whatever reason, the yearbook fund, well, it's either a -5, -6, -7, or any other numbers this way. Any numbers less than a -5, because when it's no more than -5, in class I talk about it, and I switch the phrase. I say, if for your birthday party you're told you can have no more than 5 people, can you have 7 people come to your birthday party when you can have no more than 5? Nope. So that's what we're looking at. Could you have 6 people? Nope. If someone told you can have no more than 5 people at your birthday party, can you have 5 people? Yeah. Could you have 4 people? Yeah. 3 people? Yeah. 0 people? Yeah, but you wouldn't want to have 0 people at your birthday party. Notice the number 5 is included because -5 is no more than -5. So fast. That's why when we see these phrases like this, x greater than -5, when we're picking numbers to make that true, can it be exactly this? No. Why not? Because there's no equal sign. There's no greater than or equal to, so the number cannot exactly be this. We already did some number lines before, so again, you can make a number line super fast, and when we do that, I'm going to tell you that we only need 1, 2, 3, 4, 5 lines on it, and this number goes in the middle. Or again, because it's a decimal or fraction, you can use whole numbers if you'd like. So I can go like -1, 0, 1, which gives me this guy as a -2, and this guy's a -3. So from there then, -1.5, well, that dot would go right where -1.5 is, and then greater than -1.5 means we're shading this way. Double arrow means we shaded to the right. 4 other numbers that make the statement true. Again, we can find a bunch of them that says that are not integers. So that would be like 1.3 and 13.7 or 1 1/2, all those different things. Again, saving some time, I won't graph this guy. We do in class. We can talk again about how to graph it. But the statement x is a number such that x is less than or equal to 5/2. Can it be exactly this number? Yes. Why? Because it is less than or equal to this value here. So it can include that. So when you're looking at those, again, these are some other things we're going to have to do. We're going to work with a partner. Well, no, not here, not in class. We do it together. And since it's a video, we're going to do it fast. So here, write an inequality statement. So you put down a variable, and then you put the number where the dot is at. Notice that's a closed dot. So then we are either going to need the less than or the greater than or equal to sign. Notice which way the shading goes. Since it's going this way, what are those numbers? How do they compare to -2? Are they greater or are they less than? Since the numbers shaded are greater than a -2, and that's a closed dot, this is the inequality for x is greater than or equal to -2. Write out an inequality for this guy. X, and here's your -2. Wherever that dot is, that's the number in our answer. From there, open circle, that means we're either going to have the greater than symbol or the less than symbol. Notice again, we're shaded this way. How do these numbers compare? How does 8 compare to -2? 8 is greater than, so the numbers are shaded are greater than -2. This inequality, again, you put down the variable, you put down the number where the dot is. Since it's a closed dot, that means it's going to be equal to. So less than or equal to, or greater than or equal to. I tell you in class, put down that line right away so we don't forget it. And since that's shaded left, these are shaded less than, so we want that less than or equal to sign. Last one, x and -2. Again, those come from there. They come from, you pick a variable, because we have all these numbers shaded. You put down where the circle's at as your answer. Since it's an open dot, we're going to have just a symbol, no line underneath. And this one is less than or equal to. Not talking about which way arrows point. We're talking about the values. The value of the numbers shaded are less than -2.